Mathematical modeling, a course dedicated to so-called mathematical models, simplified and formalized models of reality. It begins with the classical economy macro models of Leontief, cost issue and its generalizations. Microeconomics for diversified economy requires a balance between the different branches. Every industry is, on the one hand, the manufacturer, on the other, the consumer of the products manufactured by the other industries. There is the problem of calculating the relationship between branches through the issue of consumption and production of all kinds. This problem was first formulated in the works written by well-known American economist Wassily Leontief in 1936. Next, we consider the models of microeconomics, the concept of production function, the optimal production plan, the main production functions. We study the investment and the amount of labor expended as the main factors of the production function, the marginal rate of substitution of capital for labor. Separate sections are devoted to the mathematical foundations of the theory of consumption, some issues of economic dynamics, a model of economic growth. The next major section, econometric modeling. We use theoretical models to describe and explain the observed processes and collect statistical data in order to construct an empirical and model validation. Thanks to the machine econometric methods, it's available to analyze and forecast economic data based on statistics. The problem of forecasting the key economic indicators is very relevant and anyway is solved in many governmental and non-governmental organizations in Russia and abroad. Purpose of forecasting the key indicators of the state of the economy as inflation, balance of trade, GDP growth may be different. This is prediction of crisis, demand forecasting and business performance, and maintain stability. In the lectures, there are considered the stationary and non-stationary time series data, autoregression, vector autoregression model, the presence of multicollinearity, the generalized least squares methods. Lastly, the final section of the course is devoted to simulations. Simulation modeling is a special case of mathematical modeling. There is a class of objects for which, for various reasons, have not been developed analytical model or not developed methods for solving the resulting model. In this case, an analytical model is replaced by the stimulator or stimulation model. Stimulation modeling is sometimes called obtaining numerical solutions to partial problems formulated on the basis of analytical solutions or by using numerical methods. Mainly two types of stimulation are discussed in these lectures. Discrete event simulation, which are abstracted from the continuous nature of the events and deals only with the main events of the modeled system, and agent-based modeling that is used to study decentralized systems, the dynamics of the operations of which is not determined by the global rules and laws, but on the contrary, when the global rules and laws are the result of the activity of individual members of the group.